This video is the next video in the algebra set of videos, and in this video we're going to be looking at quadratic equations. In the first part of this video we're going to be looking at solving quadratic equations using factors. The most important thing to note here is that the solutions to a quadratic equation are known as the roots. You'll also come across this when you're looking at functions, and roots are where the graph of a quadratic function crosses the x-axis, i.e. where y is equal to 0. In example 2.1, we're going to look at 3 different types of equations that are quadratic, and we're going to solve them. Remember that a quadratic equation is the same as a quadratic expression in the sense that the reason why it's quadratic is that it has x squared in the expression. In part A, we're asked to solve the equation x squared minus 5x minus 14 is equal to 0. This is a quadratic expression that has the x squared, the x, and the number present. In part A, we're asked to solve x squared minus 5x minus 14 is equal to 0. This quadratic is in the form ax squared plus bx plus c. From the previous algebra videos, you should be okay with factorising an algebraic expression in the form ax squared plus bx plus c. When we have to solve an equation that's in the form ax squared plus bx plus c, we can solve it using factors that can be found by factorising the equation in the same way you would factorise a quadratic expression. Therefore here, a is equal to 1, b is equal to minus 5, and c is equal to minus 14. I'm going to multiply a by c. That will give me 1 by minus 14, which is equal to minus 14. Next, we write down the numbers that when multiplied give us minus 14. We can begin with minus 14 by 1 or 14 by minus 1. We'll also have 7 by minus 2 or minus 7 by 2. And there are no other integers that can be multiplied together to give minus 14. We then need to add these numbers together and choose the numbers that when added give us minus 5. Minus 14 plus 1 will give us minus 13, so it's not that one. 14 minus 1 will give us 13, it's not that one. 7 minus 2 will give us 5, which is close because we're looking for minus 5 but not close enough. And we have minus 7 plus 2, which will give us minus 5. Then we rewrite the quadratic equation. However, we're replacing the minus 5x with minus 7x plus 2x. We haven't done anything to the quadratic equation, as we could go minus 7 plus 2x, which will just bring us back to minus 5x. Then we underline the first two terms and the second two terms and factor both the first two and the second two terms. In the first two terms, we have x squared minus 7x, and we can factor out an x from both of those, leaving us with x and minus 7. And in the second two terms, we have x squared minus 14, and we can factor out a 2, leaving us with x and minus 7. Here then, we have the inside guys being the same, the x minus 7 and the x minus 7, meaning that we can write the outside guys together and the inside guys together. As x plus 2 multiplied by x minus 7 is going to be equal to 0, both of these must be 0. So we get x plus 2 is equal to 0 and x minus 7 is equal to 0. To find the solutions then, we can minus 2 from both sides on the left, so we get x is equal to minus 2, and on the right one we can plus 7 to both sides to get that x is equal to 7. So when we're looking to solve the equations, we've now found that x squared minus 5x minus 14, when equal to 0, we get the value x equal to minus 2 and x equal to 7. What that actually means in terms of the solutions is if we were to draw a graph of this, we have a quadratic equation, and that quadratic equation is x squared minus 5x minus 14. So it's a U-shaped graph, and it crosses the x-axis at minus 2 and at 7. So this point here that I'm highlighting in red would have x equal to -2, which would be here, and x equal to 7, which would be here. The second quadratic is 2x squared minus 9x is equal to 0. This quadratic is a little bit different as it has no number. But if we write it down here, we have 2x squared minus 9x is equal to 0. This one is a little bit faster to solve. What we have to do is we have to decide what we can divide out of 2x squared and minus 9x, and we can divide an x out of both. That will leave us with 2x minus 9, and that's going to be equal to 0. As x multiplied by 2x minus 9 is equal to 0, the x will have to be equal to 0, and the 2x minus 9 will also have to be equal to 0. We can then figure out what the x is equal to when 2x minus 9 is equal to 0 by, first of all, plussing 9 to both sides, leaving us with 2x is equal to 9. And then we divide both sides by 2, and we'll find that x is equal to 9 over 2, or 4.5. Therefore, when we solve the equation 2x squared minus 9x is equal to 0, we get two values for x. We get x is equal to 0, and we get x is equal to 9 over 2. Finally then, looking at the last question, we have 4x squared minus 25 is equal to 0. In this particular one, when we have the quadratic, we have an x squared, but we don't have an x, and we do have a number. To solve this, we need to bring the number to one side and the x to the other. So I'm going to plus 25 to both sides, which will leave us with 4x squared is equal to 25. Then we'll divide both sides by 4 to get the x on its own, and we'll be left with x squared is equal to 25 divided by 4. Bringing this up here so we can finish it, I'm going to square root both sides to get the x by itself, and we'll be left with the square root of 25 over 4, which, using the law of the indices, which we'll be having a look at later on in the algebra set of videos, we get the square root of 25 over the square root of 4. The square root of 25 will give us 5, and the square root of 4 will give us 2. So we'll end up with plus or minus 5 over 2, as minus 2 by minus 2 will give us 4, and minus 5 by minus 5 will also give us 25. That brings us to an end of the first video on quadratic equations, which is all about solving quadratic equations using factors.